So what I want us to start with, I know that there are some that we've already done this part, but then I want to touch it again so that we can, so that the others who are not here can also get the same concept, right? So let me do this. Yeah. So first we're gonna start with the simplest concept of them all, which is a comparison test. So I'm just gonna write like this. Just gonna write comparison test. So this will be the third time I touch it, right? With a reason. So I have a proper reason to touch this the most, because it's going to come. So this is one of the tests that there's no way a question paper can come without comparison test. So when we are having a comparison test, we can define it as follows. We can say, let's suppose let's suppose that we have two series. Obviously we should have two series, right? Suppose that we have two series. The first one, which is the summation of A of n, and the second one is the summation of B of n. All right. So now we know that both A of n and B of n should be positive. You see, right? So they should be positive for all n. And also we should have that in this condition we should have that let me not say then, let me say then we're going to have 1. So now we can say that if the summation of B of n, now I can say that if the summation of B of n is convergent, and A of n is less or equal to B of n, then the summation of A of n is also convergent. You see, right? Then the second one, we can say that if the summation of B of n is convergent, if this is convergent, and now the case we have that now A of n is the one that is bigger than B of n, then we can say that the summation of, not convergent, this one is divergent, that I wanted to write divergent. This is divergent. And also the summation of A of n is divergent. We see, right? So which means that if we come across any questions that we can look at, we can be able to solve these, right? So now let's say this, let's say we're given this example, let's say we're given this question. So we're given this question 1. Now let's say they say we should determine if the following series converges or diverges. Right, and the series is the summation so of n equals to 1 up until infinity over n squared plus 2 over n to the 4 plus 5. We see, right? So now first of all, what we need to do, so let me just write solutions. So maybe let me just write a solution. First, what we need to do is to let this be a of n. That is the first approach. We should let a of n be equals to n squared plus 2 over n to the 4 plus 5. See, right? Which this obviously is greater than 0. Right? Which this is greater than 0, but I won't write that. And then, now since I have a of n, according to the definition, it says that I need two series a of n and b of n. A of n and b of n. You see, right? So now I need to generate a b of n so that I can compare this. You see, right? So I can compare this. So now it means that I can come up with b of n. Now I can say that b of n is, so b of n can be, I could reduce the denominator, right? I could reduce this to be this we know. I could put this n squared plus 2 over n to the 4. If I wanted, I could do that, right? So I could reduce that, or I reduce both. Right? So I said that the only way you can reduce the numerator and denominator, let me give you the steps. So the question is, how can I reduce the denominator? You can reduce the denominator if this is negative, right? You reduce it. If you want to reduce the numerator alone, this has to be negative. You see, right now. But if you want to reduce both of them, the denominator should be bigger than the numerator. That's like almost the best option we can choose. That will give us a of n being less than b of n. You see, right? So now we can reduce it to this, and this will give us what? This will be 1 over n squared. We say, right? So this would mean that we have now a of n. Let me take it. Yeah, let me try to change this pen. Yeah, so we know that we are supposed to check whether a of n is bigger than b of n or b of n is bigger than a of n, right? So that's what we need to check next. Yeah, so that's what we need to check next. So it means that we are going to come and say we need to check this, right? We need to check whether a of n is bigger than that or that. So what I can do now, I can plug 1 here. If I plug 1 here, I'll get 3 in the numerator, I get 4 in the denominator. If I plug 1 here, I'll get 1, and this one is bigger than this. You see, right? Let's say now I plug 2 here, I'll get 4 plus 2 is 6 on the numerator, 2 here, 2 to the 4, I think it's 16, 16 plus 5 is 21. Then if I plug the same 2 here, I'll get 4 over, now down here, I'll get 16, and this will be 1 over 4, and this still bigger than this. You see, right now? So this means that b of n is bigger than a of n, right? So we can write this. We can say since since n squared plus 2 over n to the 4 plus 5 is less than n squared over n to the 4. You see, there's no need for me to write less than or equals to, because this is strictly less than. The first value that I plugged, they were not equal. And the more I plugged more bigger values, they became less also, you see right now. So this was kept constant. So it means that now we have this. And we checked first that A of n is less than B of n. You see right now? We checked that A of n is less than Bn. Then now we need to check if it's convergent, the Bn. If it's convergent, then we can now deduce that A of n is also convergent. So we can do the same thing. Now let's say in the summation of n equals to 1 up until infinity of Bn, which is 1 over n squared, converges. If I look at it, I just examined it, it converges by P series. You see, right? Such that P is equals to 2, which is greater than 1. You see, right? Hence, also the summation of n equals to 1 of infinity of A of n, which is n squared plus 2 over n to the 4 plus 5, is also convergent, or also converges. By comparison test. You see, right? So check the syntax. We're gonna do the same thing for the next question. First, we take out, we let A of n be that, B of n be that. Then secondly, we compare them. Which one is bigger, which one is less. Usually, most of the case, when A of n is less than B of n, we focus on convergent. You see, right now? So if it was this case, we would check if it diverges or not. So I check that this is a mark. You see, right? Then we check B of n. Always we check B of n, whether it converges or diverges, whether this is greater or less. We check B of n if it converges or diverges. So I said that this converges is a mark by what? P series. You see, right? Hence, this will also converge by what? Comparison test. You get that mark. If maybe it's 5 marks, you get those 5 marks. You see, there's a mark for these. They'll be given marks by telling us what is it, or which test did you use to check if it converges. For this one, we check it alone with a certain test. We use P series so that it converges. Remember P series, if P is greater than 1, it will converge. If P is less or equals to 1, it will diverge. You see, right? And then we come to this. Now, yeah, so it's fine. Any question? Any question?
So, the sign of the inequality doesn't necessarily have to be greater than or equal to. Can choose greater than or less than.
Yeah. When I checked first, I plugged 1 here. So I used less than because of the computation. So I plugged 1 here. First I plugged 1. I got 3 over 6. You see right now, which is 1 over 2. Then here I got 1. So I realized that the first numbers are not equal. You see, right? So sometimes when you plug, you find that here get 1, here get 1. So you'd have to keep that equal sign. You see, right? So I found that it's strictly less. When I plugged the second number, I still found that I got, I think it was 6 over 21. This side I had got 1 over 4. And it was still less. You see, right? So the first number, if the first one is equal, if you find that this first one is equal, then you're going to use this to be less or equals to. But if you find out the first number which you plug is less or is greater, you're not going to put the equal sign. You see right now? That could be useful. We agree, right?
Yeah, thanks.
All right, no problem. Any other question? So there's no another question, right? All right, if it's like that, it's fine. So now we have to check for another question. Now let's come to, let's say, the second one is the same thing. Now we have so the summation. Summation of what? Can you say maybe the summation? Let's see, 1 over 3 to the n plus n. Yeah, let's do this one. So now we have this, right? So what we're gonna do first, we're going to let a of n be equals 1 over 3 to the n plus n. You see, right? We let our a of n be that. Then b of n, I said last time I said that when we want to reduce this, right, we check. We have three things for reducing, right? When it comes to reducing, we have dominating terms. We have dominating terms. We have the second one. We have non-dominating terms. Non-dominating terms. And we have constant multiple terms or multiplicative constants. Or instead of, let me not restrict it to multiplicative because they can be multiplied, right? Also, but they can be added. We can say constants or numerics, right? So now when you are cancelling, right, you start here going up. So it means that if we have that these three are in the same thing equation, let's say maybe we have 1 over 2x squared plus x plus 1. This is a constant. If we are going to cancel, we're going to start by saying this is 1 over 2x squared plus x. You see, if we're going to cancel. Secondly, if we're going to cancel this, you see this one doesn't have a constant. It only has this one is a dominated term because the degree is bigger than this one. You see, right? This one has a degree of 1. So when we're going to cancel, we would start with the non-dominating term. So it means that this would be 1 over 2x squared. You see, right? Now when we are here, we stop. You see, right? So coming back to the question that we have here, which is B, which is this series. If we're going to find for B of n, we are going to eliminate this n because it's the non-dominating term. This one dominates. You see, right? So this would be 1 over 3 to the n. We agree, right? And then now we check whether this is bigger or small. So we say that since we write, I want to check whether this one is bigger than this or it's smaller than that. Let's start by plugging 0. We started from 0, right? If I plug 0, I'll get 1 over 1, which is 1. If I plug 0 here, I'll get 1. You see that these are equal. The first number is equal, you see, right? Then if I plug 2, I get 1 over 9 plus 2 is 11, 1 over 11. And then this side, if I plug 2, I get 1 over 9. This is like this, you see, right? And then, now I come to the second one. I plug 2, I get 1 over, no, not 2, yeah, not 2, I plug here, I plug what, did I plug 2? I'm supposed to plug 1, let me check, this one is the third one. Let me plug 1 first. If I plug 1 there, I'll get 3 plus 1 is 4. If this side I plug 1, I'll get 1 over 3. So this is like this, you see. The one with a bigger denominator is the smaller one, you see, right? Then if I plug 2, you saw that if you plug 2 here, we got 11, here we got 1 over 9. You see, right? So it means that these ones is telling us that the sign for this will be this, because the equal sign is included at first. You see, right? Instead of saying less than, we'll say less or equals to. So we're going to say 1 over 3 to the n plus n is less or equals to 1 over 3 to the n. You see, right? And then now we say and we want to check whether b of n converges. You see, right? N is equal to 0 to infinity of 1 over 3 of n. So we want to check whether it converges or diverges. So the second question that comes in is, which test are we going to use? Now I come to tell you this. So here we need to check, right? We need to check if it converges or diverges. You see, right, ne? So for us to check this, now let's check whether this thing diverges or converges. For us to check this always, ne? First, you try geometric. Any question that you come across that you need to check whether it's convergent or divergent, as long as it doesn't specify which test to use, you start by geometric series. Right? Try geometric series. Secondly, you come to telescoping. Thirdly, you come to harmonic. You see, right? Then if these don't work, you can now choose any other test. You see, right? If these three don't work, you can choose any other test. Usually if they say find the sum, and also they say find the value of s of n, or they say find s after whether it's converging or diverging using the partial sums, I would prefer that you use this. You see, right? So let me just cut these and put them this side, because these are not part of the solution. I'm just writing them so you can see, right? So this will be, just put it somewhere here. Yeah. So now we go back to the question. Let's start with geometric series. And then we have 1 over 3 to the n. Geometric series, I'm going to expand it at least twice. At least 4 times. You see, if I plug 0, I'll get 1. Plus, I plug 1, I'll get 1 over 3. I plug 2, I'll get 1 over 9. I plug 3, I'll get 1 over 27. Up until it's going to infinity, so I'm going to end at infinity. If it was going to k, I was going to end at plus 1 over 3k. You see, right? So this one is going to infinity. I'll just put the dots. So now we need to find r. So the question is, how do I find r? The ratio, I can find the ratio by saying 1 over 3 divided by 1 is 1 over 3. 1 over 9 divided by 1 over 3, it's 1 over 3. 1 over 27 divided by 1 over 9 is 1 over 3. So the ratio is the same. You see, right? Now I have to ask myself, is this convergent? So this for convergence is that the absolute value of r, which is equal to 1 over 3, which is really 1 over 3, should be less than 1 for this to be convergent. You see, right? Hence, the summation of n equals to 0 of 1 over 3 to the n converges, and you see, right? And what? It converges and no, it converges by geometric series and then I say then the summation. Now I write the one for b. N equals to 0 of 1 over 3 to the n plus n, also converges by comparison test. You see, right? So, any question? So we can come to limit comparison test. Any question? So there's no question, right? All right, means that I can give you something to write. Let me say try. You're going to try. So you're going to write this. Now we have plus 7 over can have n to the 4 of sine squared n. The second one that we have is the summation until infinity of n equals to 7 4 over 1 squared minus 2n minus 3. And then the third one, summation until infinity of n equals to 0 of 2 to the n of sine squared 5n all over 4 to the n plus cos squared n. So please, you'll try this, right? You'll try this. Yeah. So now we can come to limit comparison test. Right, let's come to limit comparison test. Now we come to limit comparison test. We can say we come to limit comparison test. So we say this, right? We're gonna say that something. We suppose we have two series, right? So we're going to suppose that we have two series, which the series are as usual a of n and b of n, and they are also a of n, b of n are greater or equal to 0. You say, right? So for all n. Then we say and. So now I want to check whether this thing is convergent or divergent, right? So, but for this, we need to check using this. Okay, let me do this. I think for this one, let me be specific here. So we suppose that we have two series, right? This and this. Then let me be specific, because here there's a condition that might need a of n should be greater or equal to 0 and b of n should be greater than 0. Let me just separate them there for all n. So now we're going to define. So let's define. Now for this we should define can be anything. We should define C. Usually we use C. We should define C is the limit as n approaches infinity of a of n over b of n. You see why I didn't include 0 here on b of n, because b of n can be in the denominator. So we cannot allow it to be equal to 0. You see, right? Then we say, now we can say that if, to check for convergence, we can say that if c is greater than 0 and is finite, which means that c is less than infinity, then either both series converge or diverge, or either converge or both diverge. You see, right? So I could simply summarize this and say if c is between 0 and infinity, you see, right, then you write those both series converge or both diverge. Is that I can easily simplify that. So now it means that if we're given this, if we're given these two series, a of n, b of n. So obviously we're always given one series, right? So I'm just saying if we're given two, if we're given a of n, we generate b of n, and then we take a of n over b of n, we find its limit. We find that limit falls between 0 and negative infinity, right? And then we are good to go. So now we can do this. Now we can say, let's say I'm given the same example that we did there, that exercise we did, this exercise, let's say we should determine, we can say determine if the following and the following series converges or diverges, right? So I want to determine whether the series converges or diverges, and the series that we have is the summation, the same series that we did not so long, 1 over 3n minus n. You see, right? Then we have this series. Now let's say, now I want to do this. Did I write final class here? It's not the final class for infinite series, right? We're still gonna have more for this infinite series. So we're gonna say this now. We are going to say that since I have this, what we did there on comparison test is the same thing. I'm going to let a of n be equals 1 over 3n minus n. And we know already that b of n was what? Was 1 over 3 to the n. You see, right? Nice thing about this one is that I don't have to check whether this one is bigger than this one or that, right? Now the only thing which I need to check is a of n over b of n. And a of n is 1 over 3 to the n minus n divided by 1 over 3 to the n. You see, right? So now we can say this is 1 over 3 to the n minus n times 3 to the n over 1. And this would be 3 to the n over 3 to the n minus 1, or minus n. You see, right? And then now we can do this. Now we can say let's a of n be. We can say now let's find the limit as n approaches infinity of a of n over b of n, which would be equal to the limit as n approaches infinity of 3 to the n over 3 to the n minus 1, minus n, not 1. So we're going to say the limit as n approaches infinity. We factor out 3 to the n over, left with 1. 3 to the n, we're left with 1 minus n over 3 to the n. You see, right? And then this will cancel this. You see, right? And then this will be equal to the limit as n approaches infinity of 1 over 1 minus n over 3 to the n. You see, right? And then this will be, if I plug here, the denominator will become bigger. And if the denominator becomes bigger, this approaches 0. You see, right? So this will be 1 over 1 minus 0, which this is 1. And this one is in between 0 and infinity. And this is greater than 0. You see, right? So we can say and 1 is in between 0 and infinity. But there's no need for us to give this condition. You can say it's greater than 0. You see, right? Now we say, so 1 is greater than 0 and let me just say this, it's fine. We can say that so 1 is between, because I don't want to write a lot of things, right? So we can say write that 1 is in between, so it means that we don't have to write this here. We can write that so 1 is in between, right? So I don't want to say a lot of so I can say since, yeah, I don't want to write the since 1 is this, so you can say that by the comparison test, you see, both series must, not must, both series either converge or diverge. You see right there? Both series either diverge or converge. Now we say, but since we check now b of n, we say that since the summation of this 1 over 3 to the n converges by geometric series, I've already checked that, right? So you would do it here on the previous. And then also summation n equals to 1 over 3 to the n minus n converges by limit comparison test. You see, right? So this is similar to, let me show you something that is common between comparison test and limit comparison test. With comparison test, you find a of n and b of n. Here you only have to write your a of n, right? You write both your a of n and b of n. So the only difference is here. Here you check whether 1 is less or equal to that, but here you check the limit. Here you see, right? You check its limit. After finding the limit, you tell us that since that limit is not 0 infinity, so by the comparison test, both series either converge or diverge. You see right now? Then after you check whether b of n is converging or diverging. This is the same thing here. what you do is you check whether it's increasing or decreasing. After that, you check whether B of n is converging or diverging. Then you give us a solution. So the only difference is that after checking this, you don't have to give a reason. You say that there on comparison test, after checking the limit, you must give us this reason. This reason has a mark. You say right, this reason has a mark. So you must keep that in mind. Any question? So now, since there's no question, let's come to the second question. Now, let's say now we're given this. Let's say now that we're given, now they gave us the summation infinity n equals to 2 So n is equals to 2 of 4n squared plus n over to the third over n7 plus n to the third. Right now, so we have this. So do the same thing. We let a of n be that. We do the same thing. We let a of n be equals to 4n squared plus n over to the third n to the 7 plus n to the third. You see, right? And then we find our b of n. So for b of n, don't forget this can be less than 4n squared. Can be 4n squared plus n. I start by reducing the denominator, right? To the third. Then this would be n to the 7 plus, so n to the third, you see right now. So I get rid of that n to the third because it's the least, it's the right element. So now I get rid of that n to the third, which means that I'll be left with n to the 7. You see, right? And this would be less than. Now, if I do this, let's say I reduce this and write n squared over to the third over n7. So the bigger number was much, so the only way to check this, right, this is the other way of reducing the numerator. Remember that I said that if you want to reduce the numerator alone, this must be negative. So this one is not negative, and we have to reduce the numerator. You see, right? We must reduce the numerator because we must get rid of this wing. So since we have that wing, now we ask ourselves, how can we remove it? The only way you can remove it is if you reduce the dominating term. It's constant, not itself, but the constant. So I can get rid of this constant. I get rid of this. This would automatically make this one bigger than this. You see, right? Because this will always be bigger, right? So I always multiply it by 4. But if I get rid of that 4, now it's a different scenario. So this will be the case. So this means that our b of n would be, so whatever you do, guys, you choose, always check whether is it really like that or not. Always confirm. So b of n squared. Well, all right. So now let's check this. Let's see if we can reduce it. N squared over n. Okay, let me do this. To the third. And 4 times n 3. So this one can go out, right, as n, not n3. Let me put n6. I want to take it out as n squared. So I can have n1 times n6. So n6, when it goes out there, to go out as n. You see, right? So it means that this will go out as n squared. Yeah, n6 will go out as n squared, because if we have this, let me show you. This is the same thing as n to the 6 over 3, which is n squared. You see, right? So it would go out as that. So it means that this is 1 over n 1 over this. Yeah, it's this. So I can erase all these, then I write my b of n as that. So some they require you to do some computation before you can erase. Yes? You're saying anything? You're saying something?
Yeah, can you please explain the part where you remove the 4 from the numerator?
Oh. I removed the what?
The 4 on the numerator.
Oh, here I was saying that since I said that time that the only way you can reduce the numerator is if this is minus, you say right now. But if this is not minus, the only way we can get rid of this is if we take it out with the constant of the dominating term. You say right now.
Okay, I understand.
Yeah, so that's the only way we can do it. I'll give you guys some examples which you can look at, or some exercises actually, not examples, so you can look at them and see if you can try to apply any of these. So,
well, another question.
Yeah.
If you're saying you remove it with the constant there, so if it's n squared plus n, you still have 1 as a constant, so we remove it.
Yeah, then that one would be, to the question is, would they give you such a question? That's a question I can ask you. Because they'll give you something you can be able to apply the rules. So if there's plus n, it means that plus n can be taken out with something in the denominator. But they can't give you something like this, with something like this in the denominator with a constant of 1 here, n plus n, and they expect you to reduce. They can't. You see, no? Do you get it?
Yes.
So they'll always give you something they know that you can compute. And always confirm whether indeed this is bigger than this. So I'm going to solve this. Is it 3? It's 3, it's not 4, right? And so here we're going to have, so this will be 4, this will be 4, let me say 4 squared plus n over to the third and to the 7 plus n to the third. This will be, now we can multiply through. Let me change this to write n to the 1 over 3. So if I take this, 3 plus 2 gives us what? 7 over, so this will be 4, n to the 7 over 3. Plus, then 1 plus 3 will give us 4 over 3. So it's like we keep the base and add the exponents. Right, I'm sure we know rules. So here, we are going to factor out, since here, let's see this. Since we see that on this one, the highest degree is n to the 7, over 3, and we need to cancel it right out so we can find the limit. So, and given that also here we can factor out n to the 7. So this will be like this. I can write 4n 7 over 3 plus n to the 4 over 3 all over. I can factor out n to the 7 here. Right, and then this will be n to the 7 over 3, 4 plus, and then this one will be 1 over n. You can try to check that. How did we find that? So now you can say this. Now this will be, if I have to take this out, it will go out as cubic root of n to the 7, which is n to the 7 over 3. You see, right? So I'm going to take that. So I'll have n to the 7 over 3. Then this will be cubic root of 1 plus 1 over n to the 4. Then this cancels out. You see, right? And then now we apply the limit as n approaches infinity of a of n over the b of n. This will be equal to the limit as n approaches infinity of 4 plus 1 over n over the cubic root of 1 plus 1 over n to the 4. This will be equal to 4 plus 0 over cubic root of 1 plus 0, and this is equal to 4. You see, right? So the solution here is 4. So I say now, since 4 is in between 0 and infinity, we can say, so we check what? We check the summation of or maybe we say, so by, first before we check the summation, let's deduce here. So by the comparison test, the series either converge or diverge. You see, right? So now we need to check b of n, if it converges or diverges. B of n was 1 over cubic root of n to the 3rd. We see now. Can say now. Yeah, it's fine. So now we can say, and the summation. It started from what? It was. Where did it start from? 2 up until infinity of 1 over cubic root of n. This is the same thing as 1 over 3. You see, right? And this diverges by what? By p series, such that p is equal to 1 over 3, which is less than 1. You see, right? Hence, the summation of n equals to 2 of infinity of this is n 4n plus 4n squared plus n over cubic root of n to the 7 plus n to the 3, right? Also diverges. You see, right? So that is the case. Any question? Any question? So it means that if there's no question, I can give you certain questions to do, right? So now let me give you questions that you can compute. using the limit comparison test, right? So yeah, let me just give you, I think I can give you which one can I give you? Let me check. I can give you these ones. Let me see. Let me see one. Yeah, let me see. Let me see. Let me see. Try. Number one, the summation of infinity n equals to 1 of 1 over n. You must try this. And also number two, you must try the summation. You say n equals to 1 over n squared using the limit comparison test. And also try then lastly do these ones also with the limit comparison test, right? These ones, do them using the limit comparison test. So any question? So we don't have any question, right? Yeah, do we see that this concept is simple, right? It just needed us to look at it in a different way. So now, yeah, Aisha, I'm shocked why you guys don't have a question. So, but that's fine. So let me see what concept can we touch now. So, any question? Okay, let's do one last more, then I'll know that we have covered these, all of us, right? Now let's come to alternating series. So next time when we come, we're covering things like next time when we come, we're covering the ones like telescoping series, root test, and ratio test. Then with the root test, we're gonna cover it. But Saturday we are starting with power series, right? So this one we'll see when we're going to cover them. But this one is the most special case. We're gonna be discussing the absolute convergence and also the conditional convergence. You said that they can try to subtract marks from there and give you a question. Then yourself you prove it as a normal question. You just write it converges. Whereas it should be absolute convergent or absolute divergent. So now the question is, how do we define alternating series, right? So like we did on the comparison test and the limit comparison test, we are going to suppose. Remember, we are mathematicians. We suppose. Oh, the things of assuming are from first level. So we suppose. Now we must suppose that we have a series. Remember the other ones, comparison test and limit comparison test, we had two series, right? Now we have one series, which is our default series A of n. Then we have a series, the summation of A of n. You see, right? And this series, we are going to have either, now, but it's fine. Let me say, and A of n is greater or equal to 0 for all n. And then we say then number one, the limit, then if the limit as n approaches infinity of A of n is equal to 0, and number two, we have that A of n is a decreasing sequence. Of the series A of n, then no, let me say it's a decreasing sequence. Then this would mean that the series A of n is convergent. You see, right? Then this series is convergent. Yeah. So now here's the thing here. So suppose that we have a series A of n is that, and it should be greater than, or it should be positive. Then if we have the limit, which is 0, and we have that this is decreasing, then that is the case. Decreasing, we are trying to say that A of n is greater or equal to A of n plus 1. You see, right? So that's what we mean when we say it's decreasing. So yeah, so as time goes on, if we forget enough time, we can do proofs for these, right? Now, but if they haven't taught you that proof in class, you can tell me after this class, please, you can tell me which proofs, you can send in the group which proofs you have done in class so that we can focus on them. So we need to determine if the following series is convergent or divergent. Alright? Now, if that's the case, we have the summation of infinity from n equals to 1 minus 1 to the n plus 1 all over n. So, when we're given this question, first, we let A of n be equals to minus 1 to the n plus 1 all over n. You see, right? That's the first thing we do. We let that be the case. So now we can check the limit. So for the first, no, did I do this? No. Excuse there. I wanted to say this. I copied that one by mistake. Let me separate it. Yeah, this is our A of n. So A of n is 1 over n, right? We let A of n be 1 over n. And then now we need to find the limit first. The simplest thing to do is to find the limit, right? That is 3 marks. Then we can check if it's decreasing after. So we check the limit of A of n, which is equal to the limit of n equals to infinity of 1 over. You see, I start by writing this first. Please do so also. So this would be 0. You see, right? Then we check whether B of n is greater than or equals to B of n plus 1. For that, we see that this is 1 over n, and a of n plus 1 would be 1 over n plus 1. You see, right? So if we say that, so it means that we need to show this. We need to show this. We need to show that 1 over n is greater than 1 over n plus 1. So if I check, I need to start where I have n. You see, right? So I'm going to say n. So this is the first one. The second one, I'm going to say for all n, we have that n is equals to n. And on the right hand side, I have plus 1. You see, right? So I'll have that n. This will imply that n is less than n plus 1. You see, right? And this would imply that if now I find the inverse of this would imply that 1 over n is greater than 1 over n plus 1. So this would change, this sign will change because we flipped it, right? That sign will change. And this, we know is the same as a of n. Well, that a of n is greater than, this one is a of n plus 1. You see right now? We need to show. We need to show this. You see, right? So this is the case. Now we arrived at that point. Now,
sir,
yes.
why can't we just plug a value there to show that an is greater than an plus 1?
Yeah, they're going to mark you wrong. I plugged the value last year, they marked me wrong. Especially my club is the one that what's this? Is the one that marks this. So it's gonna tell you it didn't ask for an example, but a proof. You say right now. So plug in one, it's like counter example. You know that you can only plug numbers if you're using counter example. We remember from SM, it's either SMTB 000 logic mathematics or SMTH 012 logic mathematics. We say right now.
Okay.
Yeah, so if you plug 1 or 2 or any number, they're going to mark you wrong. So also whatever we're doing here, guys, please, you should go consult. Any of you should go consult. And then after consulting, you can come back and give us a feedback. Yeah. So now let's do this. Let's say we got this, right? So we can see that both conditions are correct, right? So now we can say that. We can say both conditions. So if I write this so we'll understand that when you understand what you're doing. It's right. Both conditions are met, and so please go consult, guys, because myself I can't go consult. You won't agree, right? So if I go there and consult about this, we'll be shocked, because I'm also usually to me these things. I've done them, so I won't agree to say. We'll say go consult to your lecturer, because it's not my lecturer. Is right? So you must go. Even if I can consult to my lecturer, maybe what my lecturer writes, it doesn't write it the same way. So you should always go. But this I was taught by him. I think he showed me this after a test, right? I asked him why did I get it wrong. Then he said you should have done it like this. But you can go and see if this is how he wants them to be, the context. So I was shown this last year. So
I think that's what he needs, because I also consulted from him about this question. He said that en plus 1 must be less than en, and you do this whole thing. Then you remove that negative part, and now 1 over something. So yeah, I think this is what he needs.
Yes. You see? Yeah, so but another one should also, you should go consult. Not just one. By virtue, I would say that all of you should just go one by one, though. You go consult, and then you see what happens. You see, right? So that would help. You should go there. You should always be at the office. That one is a very nice lecturer compared to my lecturer. You see, the one for maths. This other time I went there. So this guy, I wrote test 1, right? So on my paper, there's no wrong. You say it didn't mark me wrong. Everything I marked correct, but then it didn't give me total. You see? So I went there to ask, Why? And then the lecturer was like, hey, you should respect hierarchies. You see, right? Then he chased me out of the office. So you see, then that one won't chase. You see, next day you'll do maths, and then you come across such lecturers that are rude. You see, and then you won't have friendly relationship. You can't consult. It's like you just go to the test blind. So you should make sure now that you go consult while you still have a chance, because next day you won't have a chance. If you're going to do maths, you'll need all these things. These things are there on test 1. So that's how I was able to get everything correct, because I know this. So yeah. So now we have this. So I said that this, I can still write it as this, right? I can say that this is equals to minus 1 to the, I separated this, n squared over n squared plus 5. Then I let a of n, I can easily let a of n be equals to, so this will be equals to n squared over n squared plus 5. Alright, and then from here we can do the same thing. Now we find the limit. The first thing, we find the limit of a of n. So the limit of this, if we check, this is simple, right? It's coming from limits at infinity. If we're going to find the limit of this, already I know the answer here, because if I factor out n, this will be 5 over n squared. If I factor out n squared will be left with 1 plus 5 over n squared. Then this will be 1 plus 1 over that should be 1 over this to be like this. Let me write like this. The limit as n approaches infinity of 1 over 1 plus 0. This is 1. You see, right? So in this case, or in this level, there's no need for us to show this computation, right? You know it. You can just write that. So, but you can show. We come to the second part. So now we must check whether this a of n is decreasing or not, right? So for us to check if a of n is decreasing, I say that we're gonna say for all n. Now let's write our a of n here. Let me just give you, I always write this so I can know where I'm going, right? I know that a of n is this over n squared plus 5. I must show that this one is greater than n plus 1 squared over n plus 1 squared plus 5. I must show this. You see, right? So now I can say here, I can say for all n, this will be equals to this, which this would imply, let's look at the denominator. I focus on the denominator always. First, I have n plus 1, I have n inside the squared. You see, right now? So I can start with, this will be n, this will be less than n plus 1. Then I square both sides. I'll have n squared less than n plus 1 squared. So I said that I focus on this inside the denominator, right? Then I know that from here I need to add 5. You see, right? Then this would imply, then I need to divide by, do I need to divide? Let me see. Yeah, and this would be the case for this one. If I divide here by n squared, this would be n plus 1 squared plus 5, n plus 1 squared. Yeah, I think this will be the case. So now we say this. We say that this would imply that now we have, let me see, okay, let me simplify this. I want to say something that, let me check something, n squared over n squared plus n squared over 5, plus then this one plus n squared over 5 greater than n plus 1 squared over n plus 1 squared. Yeah, let me just write like this. this would be 1 over n plus 1 squared. No, not 1 plus that. This would be 1 yeah, that will be the same thing. So yeah, so yeah, especially with this one, you should go consult, right? So you can see if it does allow you to do this. So here you can try to plug those numbers and see if this will still be correct. So here we would say now that this one is going to be, let me try to plug first and check. If I plug, it starts from what? From 1, right? If I plug 1 here, this will be 6. Less than, if I plug 1 here, this will be 4 plus 5 is 7. 7 over 4. So you see that, oh, this is not correct, right? Yeah, it won't be correct for this one. I should plug to check if it's correct. Let me see if this is correct. It's not, right? It's not correct to this one. Yeah, it's not. Let's see, what can I see it was coming from? It's n squared plus it's n squared plus n squared plus 5. Yeah, I think this one, let me check if it's if this is not correct. It means that we are getting another case now. It's not correct. So oh, here's another thing, guys. I forgot this, right? Here we're supposed to get that this is 0, right? That's why here this doesn't satisfy. We're supposed to get that this is 0, right? So this is not equal to 0. You see, right? So this condition didn't satisfy, so there's no need for us to check the second one. I should have seen that. That's why this one couldn't satisfy, because this is supposed to be greater than this one. You see, right? So it doesn't satisfy. That one is not equal to 0. It should be equal to 0 for it to satisfy, right? So it's not equal to 0. So if it's not equal to 0, what does that mean? So now I can say that this condition, you see, right, doesn't meet maybe, yeah, I can write this condition failed or isn't met. Yeah, isn't met. So let me write this condition isn't met. So you see that this condition isn't met. You see, right now, and there's no reason to check the second one. You see, right? So there won't be any reason to check the second one. You see, right? So now it means that we're going to say hence we can say this. Let me say hence. Now the best option to do, right, if we find that the condition hasn't met or isn't met, we should not just deduce and say that this is a divergent series. You see, right now, we should not just deduce that. So we can apply divergent test. So we can say that by divergent test. So remember I said that if something diverges, you can check by divergence test to confirm if it does diverges, right? So we can say that by divergence test, we take the limit as n approaches infinity of all these. So, you see, right, we find its limit. We find the limit. And we know that the limit of this one is 1, right? We agree, right? So the limit of that is 1. Now, for this one, now we know that for the limit of this, now the limit as n approaches infinity, minus 1 to the n, will alternate between minus 1 and 1. You see, right? So the limit of that will alternate between minus and 1, minus 1 and 1. You see, right? Therefore, the limit doesn't exist. You see, right? The limit doesn't exist. So this limit doesn't exist. So we can say that divergence test shows that the series diverges. Yes, right. I just confirmed that. So you can just take the question from here and ask, say, are you allowed to deduce that this thing diverges? If it says yes, then you're good to go. But if it says no, you can meet these conditions. So, any question? Let me give you something to write. While you have any question, you can ask. Let me say, try this. Then we can end the session. Infinity n equals to 2 over cos of n pi all over root of n. Then we write the second one. We can say that on the second one we can have, what can we have? Summation n equals to 0. We can have minus 1 minus 3 root of n over n plus 4. Yeah, try this. Try to write this, you compute them, and we see what you get. So we'll see what else are we left with to do. So we can take it from there. Yeah, any question?